Hello everyone, we are going to continue working on our two video modules that is specifically focusing on using visualizations and data integration to finding patterns in our data. In this module, we've been working on electricity consumption data. In the first video, we looked at the couple of possible visualization that showed us a lot of pattern about the data. And now we are going to see an example of data integration. So in the data, we didn't have what we needed for another useful visualization. So now we are going to get that data from another source and see how they can be integrated to our already pre-processed data and see how this visualization will actually show us more pattern. So let's get to it. So a lot of the things that are here has already been done in the previous videos that we've been pre-processing this data, and also in the previous video we also did change our data from a long format to a wide format. And this was the last visual that we were able to see, this one that is being run. So this is what we made based on each weekday. We have a visual, and the color of the line plots are the colors that specify each season. So blue specify blue is for winter, green is for spring, red is for summer, and gray is for autumn. We were able to see some patterns as far as the seasons on the visuals, but we wanted to see if we could now create these visuals using temperature. So the temperature is in another source, and it's provided in the temperature 2016.csv file. So once I read this data, I can see that this data has the temperature of 2016 for the whole year. You can see for the whole year per every 30 minutes. And what I really want, however, is a temperature for every day, an average temperature for every day. So for me to be able to integrate this data, first I need to find the right time gaps in my data. So to do this, first I go through a couple of data pre-processing, making sure that I have the every year, and also another things I need to pay attention to is because I want to eventually join this data or integrate this data with this data frame, I need to make sure that I have a column or the index of this data frame is the same as the index of this new data frame I'm creating, or I'm like trying to integrate or join to this data frame. So what I will be doing here is to make sure that I have a date column exactly the same format as my earlier data frame, my Y data frame. So that's what I have done here. Now once I run this, I have that date that is exactly the same format as the date in my Y data frame. So once I have this, it's so simple. All I need to do is to do a group by based on this column and do an average. And even though there might be some missing values in this data, they're not going to be important now because I'm doing a group by and average. And even if there is one or two missing values, that average is going to cancel itself out, and that's not going to be an issue. So once I run this, now I have a series that the index is date, and I have an average for the temperature for every day. So what I do here, now I change that daily temperature average, and I join it to my Y data frame. But before doing that, I am re-indexing the setting the index as date, because the date is what these two data has in common. So once I run this, now my new data has data as the index, and let me go to the next one. So new ydf3 dot head. So you can see everything here. So temperature is added at the end of the data. So now I have the temperature. So I should possibly be able to code the coloring in a way that the higher temperature are sort of redder than the lower temperature, or like blue or lower temperature. So to do this, we need to figure out a way to sort of color code ourselves, because we're creating this visual from scratch. So let's look at this code that I have done here. I say I want to have 80 different colors with different shades. My red is basically a number between 0 and 1 by intervals or steps of 1/80. And blue is the opposite, it's from 1 to 0 by the same intervals. And the green is 0.25. So now if I run this code, I will have a line that each of these points are a shade of green, a shade of blue or red. So here I have the maximum blue and the minimum red, so it's completely blue, and it moves all the way to more red. And I could be changing this green color. If I change that, the shade changes a little bit, and it will turn into different shades. So you want to find sort of a shade that works as far as making a sense of sort of hot and cold color, basically. So now they know how to create different shades of colors. Here I have implemented that. My red is basically going to be from 0 to 1, but 0 is when the minimum temperature out of all of the possible temperature in the data, and the 1 is the maximum temperature. So I'm using the standardization formula to sort of standardize the temperature by the minimum and maximum, and every time the temperature is high, it's going to be a higher value, and if it's lower, it's going to be lower value, but it's going to be between 0 and 1. And I defined blue as 1 minus red, and the green is 0.25, what we experimented here to figure out sort of like this represent the best heat as far as like blue being cold and the red being hot. Once I get to the deciding the color, I use these arrays to specify the specific color or the specific redness and blueness that comes from the temperature based on the data. And once I run this, now I will have different shades of blue and greens in my visuals. So there we go. As we can see, the hotter the days are, and the lower the temperature that's been used. And we can see that actually there is that correlation between temperature and electricity. So based on using visualization, we're able to see that two very important factors as far as predicting electricity is the weekday and also the weather. And here we're able to use temperature to sort of like show that, but there might be other metrics that it could actually be helpful in prediction. It could be the level of humidity, wind, and all of those things that nowadays are calculated and measured and should be possibly available.